Welcome to the wonderful world of Python programming. I'm going to assume that you have Python installed in your computer and you have figured out how to start the Python interpreter. The interpreter is just a piece of computer program which takes your commands one by one and executes them then and there. Later on, once we get more used to the game, we will also write Python scripts, things which most people would call Python programs. So these are usually more complicated, have a lot of commands written in a single file and then run as a bunch. But for the time being, let's just play with the interpreter. And the way in which you start the interpreter may differ depending on your system. In most cases, if you're using Windows, you can perhaps click on a button somewhere and you will start the Python interpreter. In my system, which is a Linux terminal-based system, I've opened the terminal, I've typed Python, and I'm using Python 3, just since most of you, if you have a new installation, will have Python 3 by default. And so, I've started the interpreter. And if you look carefully here, there are three greater than signs on the left. This is the Python prompt. It's telling you that the interpreter is ready and waiting for you to give a command. Now, what can you do with the interpreter? Well, you can do many things. You can actually use it just like a calculator. For example, you can ask it something simple like, what is 3 plus 4? Something slightly more complicated, what is 3 times 5? There is no into sign in your keyboard, but the star symbol works for multiplication. So 3 times 5 is just 3 star 5, and the interpreter beautifully replies 15. You can divide, and here the division is the slash, and you get 0.6. You can also do something else, use 2 slash signs and do the same calculation. Now, surprise, surprise, you get 0. Well, that's because when you use a double slash, what Python is doing is calculating the quotient. So, you're asking how many times does 5 go in 3? The answer is not at all. So, that's why you're getting 0. So, this is just what you did when you learned division for the very first time. You learned quotient and remainder. So this is the quotient. 7 by double by 4 is 1 because 4 goes once in 7. 7 slash 4 on the other hand is just division, 1.75. Well, we talked about quotienting. What about the remainder? That's the percent sign. So percent sign, when you put it between two integers, gives you the remainder when the first integer, the first whole number, is divided by the second whole number. And here you get 3, which is of course the remainder which you get when you try dividing 7 by 4. So, this is just basic mathematics. You can do something slightly more complicated. For example, you can raise 3 to the power 5, which means you are multiplying 3 by itself 5 times. So 3 times 3 times 3 times 3 times 3. And the answer is 243. Well, how big a number can you deal with? That actually is slightly complicated as a question. It depends on what kind of numbers you're talking about. If you're talking about integers, well, whole numbers, the answer is you can actually deal with very, very large numbers. Say 3 to the power 50 is this, no problem at all. 500, well, notice that it becomes pretty long. It's not fitting in a single line, but you're getting an exact answer. 5,000, well, it's so big, it has crawled off the screen, but you can see when I go back that Python has actually calculated and returned to you the exact answer for 3 to the power 5,000. So how big a whole number can you deal with? The answer is basically limited by your computer's memory size, and that can be very, very large indeed. So for the time being, don't worry about how big a number you can deal with. If you're dealing with integers, whole numbers, there is practically no limit. Of course, I can try going further, let's say trying to calculate the 50,000 power of 3, and that's even bigger, 500,000 power of 3. Now, it took some time before it could calculate, so calculating a number this large and more importantly displaying such a huge number on your screen takes quite a bit of time. When I say quite a bit of time, it's quite a bit of time in terms of computers. Earlier, what was happening was literally in the blink of an eye. Actually, it took a lot less than the blink of an eye. But this last calculation took some time. But let's not worry about very large numbers right now. We will come back to this issue later. But let's just recap. We can use Python interpreter to add, subtract. I did not show you that, but subtraction works just as fine. Multiplication works. Remember, multiplication is a star, division, slash, quotienting, double slash, remainder, percent, and exponentiation or taking a power, that's double star. So this is the kind of easy mathematics you can immediately do with the Python interpreter. Are whole numbers the only things you can deal with? No. Whole numbers are basically examples of what is called the integer data type. That's a complicated sounding way of saying that these numbers are just whole numbers without any decimal point. On the other hand, you can deal with numbers like this, 3.5 into 2.4. And the answer comes out just as fine, just as easily. And as you may have noticed, the space I gave in front of the star actually played no role. Typically, it's a good idea to actually place a space both before and after the star. That's simply because it makes your code look good. But the result, of course, does not depend on that. So white spaces in the middle of a command. White spaces are just things like these spaces and other special characters which don't show up, as you will learn later. Those white spaces are ignored when they're in the middle of a command. But they make your code look better, so very often people do use it. But there's one very important place where white spaces cannot be given, which is this. Suppose I did this. This looks exactly like what I typed before, except for one tiny thing. And the tiny thing is, here at the very beginning of the command, I've left a space. And now Python is complaining. It's telling you that there is an error. Not only that, it is telling you that there is an indentation error. Unexpected indent. The rule in Python is commands have to start flush from the left hand side. You can't just write anywhere you want. There are special situations where you will have to make an indent, but those are expected indents. The problem here is that the interpreter did not expect an indent at the beginning of your line, and so that's what it was complaining about. So this is very important. So when you start writing your own code, this is something you have to be very careful about. Spaces in the beginning of a command is a big no-no. We're coming back to the kind of number we are dealing with here. Our earlier examples were all with whole numbers, things which technically were called integers or int in the language of computers. These are of course not whole numbers, 3.5, 2.4, etc. And they are actually called floating point numbers. Now the name may sound a bit strange, but floating point or float, which is what we usually call them, is really a name given because you can put the point something like at the end of the first digit, or you can put it at the end of the second one, or maybe at the very end. So the floating point floats. It can move from position to position inside your number, which is why this is called a floating point. So the kind of numbers we deal with in Python are integers and floating points. There are also other kinds of numbers which you will learn of later, like complex numbers. But for the time being, let's forget about them. Knowing about integers and floats is more than enough for most purposes. But these are not the only kind of things Python deals with. Floating points and integers are the most basic kind of things that you deal with. However, there are other things. Things like names, for example. Want to write your name, or in this case, let's write my name. Now, if I just type my name on the interpreter and hit the enter key, I did not perhaps tell you that, but at the end of every command, I'm hitting the enter key. I'm getting an invalid syntax statement. Invalid because somewhere in between there's a space and it doesn't really understand what's happening. Maybe let's just try to type my first name. Now I get an error, an entirely different kind of error. It's saying name error. What went wrong here? Well, here what went wrong is something rather complicated. Python thought that I was talking about a variable name. We're going to talk about variables and their names soon. But for the time being, just realize one thing. Python is trying to figure out what this thing, ANANDA, means. And it has no prior reference to that, and so it's just saying that it doesn't know this name. That's what a name error really means. If on the other hand I really meant my name directly, what I would have to do is put it within quotes. And then even putting a space inside is fine, so I could just type the whole name and put the whole thing within quotes. This is a perfectly valid thing for Python to talk about, and this is called a string. A string is a series of letters, numbers, other characters which you can put in and talk about together. The only one important thing is you have to put them within quotes to tell Python that this is not a name of a variable or name of some other object. It is just literally what it says. It's a string. Now, what kind of quotes should you use? Should you use single quotes or double quotes? The answer is, it doesn't matter. But what does matter is that if you start with a double quote, you have to end with a double quote. But there's something else. Suppose I wanted to type Ananda Dashgupta's code. If I did this, Python will give me an error message. Because the moment it sees this quote sign here, which I meant, of course, as an apostrophe, Python will think that the string has ended right here, and then it does not understand whatever else that you are putting in after that. So it's telling you that there is a syntax error. Now you can avoid this by putting the entire string inside double quotes. If you do that, a single quote will just not end the string. It will be considered as part of the string. Okay, in the same way, if you have a double quote inside your string, maybe you are trying to quote something that somebody said and you want to write that down as a string, you have to begin or end your string with single quotes. Some of you may be wondering what happens if you have a single quote and a double quote both in your string. The answer to that I will give you later. So we have met so far integers, floating points and strings. It's high time that we also met variables. We have already met something which Python thought was a variable but wasn't, and that's why we got a syntax error. Let's do something like this. My name, this is the name of a variable, and I am writing my name equals so you can think of a variable as a box which is really a part of your computer memory where you are trying to store this result of the expression on the right hand side of the equal to sign. The equal to is strictly speaking not really an equal to sign. It's more like an assignment sign. What you are telling Python is take this string, a bunch of letters inside the quotes, whatever is there, take this whole thing and push it into a region in memory which you're going to call my name. So the my name here on this side is not something which has quotes. It is the name of a variable, not a string. On the right hand side you have a string in this case, and what Python does is takes the string, pushes it into this variable location. So now if I check what is there in the variable my name by using Python's inbuilt print function, it's going to tell me exactly what is there inside. And no surprises here, whatever I put in is what is inside. Of course, you don't have to give a fixed thing only to a variable. For example, we could try something like this. And then what Python does is calculates whatever is there on the right hand side of this equal to sign, which remember is not really equal to its assignment. It calculates whatever is here, 4 times 5 is 20, and the result of that calculation gets stored in the variable whose name is given on the left hand side. So if I now try printing the result by putting the name of what I want to print, the name of the variable I want to print inside a bracket after the print function call, I do get 20. Now, apart from integers, floating points and strings, there are also many other kinds of very important Python data types. We will meet lists, tuples, dictionaries and stuff like that in the coming lectures, but this should do for now. Before I end this video, let me give you a glimpse of what we are going to do in the next class. We are going to use something which should remind some of you of your earlier classes if you have used something called something like a programming language called Logo, which is used to draw on screen. And Python actually has something inside which draws pictures like that. To use that, you will have to use a mantra at the beginning. Right now, I'm not going to explain what this mantra does. We are going to talk about it in great detail later. For the time being, just remember, if you want to draw pictures using the turtle module, that's the formal name of this thing, you have to use at the very beginning a statement like this: from turtle import star. Exactly what this means, we are going to describe later. But once we have done this, what we can next do is something like this. You can type something like forward 100. And what that does, okay, it happened too quickly for you to see now, but you may have noticed that there's a line on the screen with an arrowhead at the end, and that this arrowhead is exactly what is called a turtle. To see this again, let's use a reset function from the turtle module. All these things, names followed by a bracket within which I can either put in something or leave empty, as in this case, are examples of function calls. You are calling a function which turtle provides to you, and this is to reset the canvas. Resetting the canvas puts the turtle, this tiny arrowhead, back at the middle of the canvas, and let me make my terminal slightly smaller so that you can see the whole canvas now. And because I want you to see the turtle a bit better, let's increase the width of the turtle. This will increase not the size of the arrowhead, but the width of the line will draw when the arrowhead moves. Now that we are all set, let's show you what's happening again. If I hit the forward 100 command again, what the turtle does is that it moves forward to 100 units on the screen. Forward means simply forward in the direction in which it is pointing right now. By default, its stars are pointing to the right, so it is going to move to the right. And 100 units is, technically speaking, what is called 100 pixels. If you don't understand what that is, just think of 100 times some arbitrary length unit. And when it moves, it leaves a line at the end. Now what I can do after that is something like this. Now you type write 90. This instruction tells the turtle to turn right from the way it's facing, to 90 degrees. And notice that if you do that, you will have very keen eyesight to notice this, but the turtle has actually turned right to 90 degrees. It has not moved, so no line is drawn on the screen. It's now pointing down. Now, if I hit forward 100 again, it's going to move forward. Right 90 again forward 100, again right 90, it's turning right to the right to 90 degrees every time, and then I type forward 100. This makes the whole thing come back. So now I've seen that by applying forward 100, right 94 times, in fact, let me finish with the right 90 so that I end up with the turtle pointing the same way as it did when it started. I now have drawn a perfect square on the screen. Now this, many of you will think, is child's play, and it is, but it's great fun to use a turtle to draw more and more complicated figures. We are going to use this in the next lecture, not only to draw figures, but to learn more and more about how to use the computer programming language, Python in particular, but perhaps more importantly, we will learn about various things which computer programmers use, various aspects of computer programming language, in a nice and fun way using the turtle. So bye for now. See you in the next lecture, where we will have a lot of fun with the turtle module.